Alright, so I think I'm recording. Let's take a look at this problem we're looking at review problems of skill packet 4 that's polynomial and rational functions. And they've given us a polynomial function that's partially factored. Um, and they've given us a table. Now, the table here may be too long. I doubt if there's this many zeros and stuff. So you can't really infer how many answers are going to be by the size of the table. Don't think that you have to fill in the entire table, every row here. So to find the zeros or the x-intercepts of this polynomial function, we let y equal 0 and we solve this equation. So we want to factor it completely. Here we have a difference of perfect squares. So we've got that 4x squared minus 9 factors to 2x plus 3 times 2x minus 3. And then if we can't factor this next trinomial, we would have to use the quadratic formula, but I suspect that it'll factor. Need to move that up a little bit. Alright. So with 2 being a prime number, 2x times x, it's much more difficult to factor trinomials when the leading coefficient is a composite number with a lot of factors, and if the constant term here is a composite number with a lot of factors. See, with the -6, we know that we're going to have positive and negative, and with the 6, it's either going to be 1 times 6 or 2 times 3. So let's try the 2 and the 3. 2x times 2 is 4x, and 4x minus 3x is 1x. So there, we found it. So let's notice that we have x plus 2 and x plus 2 over here, and that we can write that as x plus 2 quantity squared, and that we have 2x minus 3 and 2x minus 3, and we can write that as 2x minus 3 squared, and then we have a factor of 2x plus 3. So in factored form, we can see that we've got 3 zeros, -2, that add 3 and divide by 2, 3 halves, and -3 halves. And with the factor x plus 2, it has a multiplicity of 2. So we know that that's a touch and turn because it's an even multiplicity. With the 3 halves, its multiplicity is 2, so it's a touch and turn. Here, the multiplicity is odd. The multiplicity is 1, so that's a cross. What that means, this is describing how the graph intersects the x-axis. With a touch, we're saying that it comes down and touches it and goes back up from above or below. So at -2, it's doing one of those things. And the same at 3 halves. Now for a cross, it's either from above that it's crossing like that, or from below it's coming and crossing the x-axis there. If this multiplicity were say a 4 or a 6, it would still do a touch and turn. It would just be a lot more flat, close to where it's coming down to touching. And the same thing, if this one were a 3 or a 5 or something like that, it's going to cross, but it's going to come in and almost get flat. It's going to cross and then come out and go up like that. So alright, so we found that -2, 3 halves, -3 halves. We got that in our table. We've answered everything they wanted. Let's move on to see if the next one's similar. Yeah, so let's go ahead and do these in the same video. So this time it's not given to me in factored form. And I don't have any factor by grouping or any techniques that would factor this besides my rational zero theorem. So I look at 9 and I write down factors of 9 for my possible numerator. I look at the leading coefficient of 1, and since it's 1, this generates my list of possible rational functions because it's this divided by 1, that divided by 1. So here's my list. So let's jump in and see if we can find a zero remainder. My polynomial function is presented to me in standard form. There are no missing x terms. Listen to Donnie Baker. So 1 doesn't provide me with a 0. So let's try -1. So there we go, we have 1. So now we can factor this, and this 1x squared 6x plus 9, that's a quadratic. That'll be a perfect square. We can see that probably already. In factored form, it's written as x plus 1, and this x squared plus 6x plus 9, if we set this equal to 0, this factors as a perfect square, x plus 3 quantity squared. So we have two zeros. We've got one at -1 that has a multiplicity of 1. We've got one at -3 that has a multiplicity of 2. So we have a 0 at -1. We have a 0 at -3. Since the multiplicity is odd, the graph crosses the x-axis, and at x equals -3, it does a touch and turn because that's an even. The multiplicity is 2, and that's an even number. Alright, so let's see. Alright, so let's now this time I see that I have a greatest common factor, and I always want to start with that. So all of these are even numbers, and they all contain at least an x to the third. And so now I have 2x. I need to add up to 5, so 2x squared, 5x, and minus 12, right? Alright, so if we set this equal to 0, the 2 is prime. 2 times 1 is 2. 2x times x is 2x squared. Now with 12, we're starting to get into multiple combinations here of 1 and 12, 2 and 6, 3 and 4. With it being negative, one of them is going to be positive, one of them is going to be negative. We need we need the middle terms to add up to positive 5x. So we need this. What do we need? Well, if you can't see the sometimes you'll be able to see the combination quickly, and many of you can see it oftentimes quicker than I can. We've got this x method that will that will help us. We've got -24 x squared if I multiply the first term times the last term. Two numbers that when multiplied together give me the -24 but add up to positive 5. And then in the body of a table, in the body of a table I have 2x squared. The one diagonal has the first term and the last term of the trinomial, and along the other diagonal is the values in my x. So if I factor here, both of these are divisible by 4, both of these by -3, x is common to both of these, and both of these are an even number and they have an x. So this factors to 2x minus 3 and x plus 4. So many of you can see that without going through the table. It's just that, like I say, when you have a lot of different possible combinations, it is nice. It is helpful. So this first factor right here is 0 if x is 0. This next factor will be 0 if x is 3 halves. And here if x is negative 4. So we've got 0, 3 halves, and I should be careful not put my parentheses like that. I probably should have put the 3 on the outside so that I can identify the multiplicity. This multiplicity is odd, so it will cross. That's how it intersects the x-axis. This multiplicity is 1, it's odd, so it'll cross. And this multiplicity is 1, so it'll cross. So that's what they wanted with what we wanted with problem 17. That may be it on that. Yeah, I'll do this next one on another video. I'll talk to you later. Bye.